So let's look at part E. Part E of this free response is saying that the rate at which Joe Exotic hires new employees is represented by the differential equation dy dt equals the quantity 1 minus y e to the 2t. And we're asked to find the particular solution y of t using the initial condition y of 0 equals 3. So here we're being asked to use our knowledge of separable differential equations. Okay, so we have a differential equation, dy dt is equal to 1 minus y e to the 2t. Okay, to start this, we need to go ahead and separate our variables. So we need to collect everything with y's on one side and everything with t's on the other side. So some quick algebra gives us dy over 1 minus y equals e to the 2t dt. Okay. Since we're trying to get, our end goal is to get y of t, we need to get rid of the derivative for dy. So we know at this point the tool for getting rid of derivatives or undoing derivatives is integration. Well, if we integrate one side, we have to integrate the other side. So taking the integral of dy over 1 minus y is going to give us natural log of 1 minus y. But there is a coefficient of -1 in front of that y, so we need to include a negative out front. So this is a chain rule, right? You can check this by seeing, is the derivative, so let's pause and think, okay, what's the derivative of negative ln of 1 minus y? Well, we know that the derivative of the natural log is just 1 over whatever's in the argument, so 1 over 1 minus y. We had a negative out front, but remember when we do the derivative, we'll have to do the chain rule, so we also have to multiply by the derivative d dy of negative y. And when we do that, we get -1 over 1 minus y times -1, or -1. Notice here, you have a negative times a negative, so you end up with +1 over 1 minus y, which is what we started with here, which is what we were integrating. Okay, so we can always check that our integration is correct by pausing and taking the derivative of what we get and see if that leads us back to what we started with in our integration. Okay, so I'm going to go ahead and erase this just so we don't get super confused. We also need, so we should include, I like to include a plus c right away, just like to remind myself. I think that Mrs. Flom has just like added 1c at the end, but I'll show how we can get that in a second. We need to go ahead and integrate the other side. The integral of e to the 2t is 1/2 e to the 2t plus another constant. Okay, again, we can pause and check this, right? We can go ahead and check this out. Is this right? If I take the derivative d dt of this function, 1/2 e to the 2t, I should hopefully get back e to the 2t. So the derivative of e to anything is just e to that same thing, but then times the derivative of the exponent. So what's the derivative of 2t? That is 2. But remember, we had a 1/2 out front, right? So this 1/2 stayed there as the coefficient. We took the derivative of e to the 2t and we got e to the 2t times 2. And you'll notice that those 2's will cancel, and that leaves us with e to the 2t, which is what we were integrating. Okay, so we again can pause and check our integration there by taking the derivative and see if we get back to where we started. Okay, so again, I like to put the two c values in there, but if you wanted to jump right to negative natural log of 1 minus y equals 1/2 e to the 2t plus 1 big constant, that's totally fine too. Okay, so at this point, there's a couple different ways that we can go about this. I'm going to choose to actually solve for C here, right? I'm going to utilize this initial condition, y of 0 equals 3. That tells me that when t equals 0, y is 3. So back here in this equation, I can go ahead and substitute in y is 3 and t is 0 to work to solve for C. So that will give me negative natural log of 1 minus 3 equals 1/2 e to the 2 times 0 plus c. Okay, this will be negative natural log of the absolute value of negative 2 is equal to just 1/2. I know that it's just 1/2 because this exponent on e becomes 0, and anything to the 0th power is just 1. Okay? And then we have our plus c. On the left-hand side, I can recognize this as just being the natural log of 2. And then I can bring over the 1/2 to solve for c. Okay, so I have found that this constant of integration is negative natural log of 2 minus 1/2. So I need to go ahead and put that back into my equation and then work to solve for y. Okay, so at this point we have negative natural log of 1 minus y equals 1/2 e to the 2t minus the natural log of 2 minus 1/2. And it's not pretty, but we can solve this equation for y. The first step is going to be to isolate the natural log. So we're going to have to divide out a negative 1. And that will give us natural log of 1 minus y equals negative 1/2 e to the 2t plus natural log of 2 plus 1/2. Okay, so in isolating that natural log and dividing out the negative 1, we've just simply flipped the sign of everything. We needed to do that in order to isolate the natural log so that we could go ahead and apply the exponential to both sides. Okay, so I'm going to bring my work up over here. In doing that, we see that on the left-hand side, your e and your natural log cancel out. Notice what's left behind, an absolute value of 1 minus y. It's not just 1 minus y, we still have to account for that absolute value. Okay, so our next line will read the absolute value of 1 minus y is equal to e raised to kind of all that craziness. So we have e, and then up in the exponent, we have everything, negative 1/2 e to the 2t plus natural log of 2 plus 1/2. Okay, so all of that is hanging up in the exponent. It's kind of messy and a lot to keep track of, but you're just going to hold fast to your algebraic rules, right? You know that when you take you raise both sides to e, you need to include all of those terms into the exponent. Okay, from here we need to go ahead and address this absolute value, and this can be a little bit tricky, but when we drop our absolute value, all we need to do on the other side is introduce a plus and a minus. Okay, so absolute value communicates plus and minus, so when we drop that on the left-hand side, we need to then introduce plus and minus on the right-hand side using our plus minus symbol. So we'll have plus minus e to the negative 1/2 e to the 2t plus natural log of 2 plus 1/2. Okay, again, that is all still up in that exponent. So we'll continue to work to isolate y. We'll subtract 1 over to both sides. That will give us negative y equals, and I'm going to write the negative 1 first so I don't get confused as to whether or not that negative 1 is in the exponent or a constant being added to it. It is a constant being added to it, so I want to make sure I communicate that super clearly. So I have negative y equals negative 1 plus or minus e to the negative 1/2 e to the 2t plus ln of 2 plus 1/2. Okay, and I almost have y isolated. Notice there's just a negative sign, so we need to divide out that negative. That will give us y equals positive 1. I'm going to go ahead and write this now as negative plus, right? Instead of plus minus, a minus plus. All that did was told me that I correctly remembered to go ahead and divide the negative out. We're going to get rid of that in a second anyway, so if you wanted to leave it as plus minus, that's totally fine, and maybe I'll do that just so it doesn't look so weird. So still we don't know, right? Plus or minus, we'll figure that out in a second. E to the negative 1/2 e to the 2t plus ln of 2 plus 1/2. Okay, so we're almost done. We need to figure out which symbol do we use. We have to pick one, right? And we're going to use our initial condition to make this determination. Okay, so if I plug in 3 for y and 0 for t, I need to figure out, do I add or subtract these two terms, right? So we have e to the negative 1/2 e to the 2 times 0 plus natural log of 2 plus 1/2. Okay, I'm going to go ahead and clean up that exponent a little bit. So still haven't decided plus or minus, but I have e raised to the negative 1/2. Notice the e to the 2 times 0 became 1. Okay, so there's really multiplication of 1 to this negative 1/2, but I don't need to write that. Plus natural log of 2 plus 1/2. And that's nice to see because we have the cancellations of the 1/2, and we are told that this then is 1 plus or minus e to the natural log of 2. We know that e and natural log are inverse functions, so this becomes 1 plus or minus 2. If I want that to be 3, I can see pretty quickly that I'm going to have to choose plus 2. Okay, so back up here in my function when I was trying to decide plus or minus, well now I know using my initial condition that it was to be the positive. So after a significant amount of work, we have our our particular solution. We have our solution that y of t is equal to 1 plus e raised to the negative 1/2 e to the 2t plus natural log of 2 plus 1/2. Okay, a ton of work, and I want to quick talk about where points came from for this. So you got 1 point for separating your variables. Okay, so 1 point right off the bat from recognizing that you needed to collect your y's to one side and your t's to the other side. You got another point for correctly integrating the left-hand side. You got a third point for correctly integrating the right-hand side. You got a fourth point for introducing plus c at the appropriate place. And then you got a fifth point for using the initial condition to solve for c. Your 6 points on this was your final answer. Okay, so what I want you guys to notice here is that you can get 5 out of 6 without having to do all of this crazy work, right? If you're pushing for that 5 on the AP exam, you definitely want to make sure that you can handle this. But I want those of you who maybe struggled with this to be aware that you can get a significant chunk of the points here by only finding your C value, right? So again, you got a point for separating for one correct integration, second correct integration, you got 2 more points. Introducing your plus c at the appropriate place was your 4th point, and then using that initial condition to solve for c was a 5th point. Okay. Properties of exponents may have left you with a slightly different answer, and I was watching for that. So if you got 6 out of 6 but don't have y of t in this form, chances are you did some manipulation with your exponents, which is totally valid. Okay, go ahead and check out the next video if you want to see what was going on with parts F, G, and